Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today, our very special guest is Wayne Garrett. Wayne Garrett is the Chief Commercial Officer for Viridi. Viridi does energy storage. So, hey, Wayne, how's it going?
Hey, Sean, how are you doing today? Thanks so much for having me on.
Yeah, I'm doing pretty good. As we said before, when we were just warming up, I'm sitting over here in the East Bay of the Bay Area in a little town called Orinda, and you are in Texas right now, I guess. Is it warm over there?
It's no, actually, believe it or not, it's kind of cool for a late summer day for Texas. Had a little bit of weather down here, but I know we're going to talk about microgrids, and today I'm actually down at one of our partners here in Dallas, Texas, setting up some training for a microgrid.
Oh, awesome. Microgrid training. I'm into that kind of stuff. Yeah.
Definitely.
So you're stabilizing that Texas grid that's been in the news a little bit over the last couple of years.
We definitely want to do a lot more of it as we move forward. No question about that.
Yeah, great. And where are you usually? Are you traveling around right now? Do you live in Texas?
So I live outside of Dallas area down in Corsicana, Texas. Also travel quite a bit over on the East Coast, of course, back up to Buffalo, New York, where Viridi's headquarters is located at. But as a chief commercial officer running around with all the sales channels that we have in North America, as you imagine, I'm on the road quite a bit.
So let's see. I know that Viridi also has a different name too, I think, from what I've seen, Viridi Parenti. Is that right?
Viridi Parente, correct.
And you do energy storage. So you have lots of different batteries of all different kinds. And it looks like you have a factory too.
We do. The factory's located up in Buffalo.
Uh-huh.
And up in Buffalo, we're building anywhere between 5 kWh all the way up to 1.2 megawatt hour systems. The 5 kWh systems that we have right now are typically used, we call it Fabio, on traffic lights that are used as a UPS backup in the event of power failure. And then we have scalable systems, which really differentiates Viridi from a lot of other battery energy storage companies, between 50 kilowatt hour packs that can be combined into a 150 kilowatt hour pack, and then those get put into a 1.2 megawatt hour pack.
Okay. Maybe we can start small and go big. So the 5 kilowatt hours, that's for traffic light backup?
Right, right. Viridi actually came out with a small, compact battery management system with IoT and a 5 kilowatt hour unit that can be placed on traffic lights to where, in the event that the traffic light fails, it automatically transitions over with UPS to that power system, keep the traffic lights on in case of emergency.
But I always like to have an excuse to run a light.
Well, and typically, listen, I have no idea, Sean, how many lights you've run in the past, but we
Uh,
like to make sure that we're keeping everything consistent between the lighting systems and making sure there's no safety issues out there, especially in an emergency situation like in a hurricane or something, where if you're in Puerto Rico, where we have deployed quite a few of these systems down there, you want to make sure that the emergency vehicles can get through to where they're needed the most. First responders are getting through, and of course, the safety of just the citizens that are down there, protecting them to making sure there's not going to be any further accidents in and above whatever's happening from an emergency situation.
yeah, one of the things about emergency situations that I see once in a while, and even recently, is there's a bunch of people stopped at a light and they're not letting the fire truck and the ambulance pass by, and they're supposed to run the light. I think they could get ticketed for not running the light in those situations. But
Exactly.
uh, so whenever that happens to me, which isn't that often, but it's like, wow, bonus. It's like I'm supposed to run a light right now and right in front of a police officer. And you also mentioned IoT, so that means Internet of Things.
Yeah,
And how
that's
does
right.
that work?
Yeah, the nice thing about what Viridi has, in addition to the battery management systems that we have, we can track each one of our systems out there in the field. So we are able to log in to the Fabio systems to identify what the battery, if it's in a charge mode or a discharge mode, what the status and the life cycle of that battery is, the battery health, bring all that information back to a front end through a program we call Vista, and keep track of the health of that battery system as it's been deployed out there in the market.
So you mentioned Favio. What's Favio?
Yeah, Fabio is the smaller traffic light system. It's the brand name that we have for those systems that are out there.
Okay. Do you have one of those, like a garage door opener that lets you change the color of the light?
No, no, I don't think we go that far.
You
We
probably wouldn't tell me.
Well, a lot of those emergency response vehicles, I think they have the ability to switch those lighting systems with the computer systems they have on the lights. We just want to make sure that the light is powered in the event that you ever have a problem with the grid.
Yep. And then I imagine too, when the power goes out, sometimes the internet goes out.
Absolutely. Now, our systems won't because we have, again, the battery backing up
Oh,
everything that we have. And of course, we're transmitting all this data via wireless. So
oh,
if
okay.
there is a situation to where you might have the grid go out, is it going to take out the transmission towers or it's going to take out one of the cell towers? We've also been looking at deploying our systems out there to make sure those are going to be resilient in the event of emergency situation like that too.
Yeah, and then you might want to hook up to satellites in case another one of those meteors comes
Come
down, like
down.
what took out the dinosaurs.
Oh, yeah, hopefully
That
that won't happen
asteroid.
anytime soon. So to that point, though, I mean, the good news about this system is while you might end up having a telecom site tower go down, the traffic light would still be operational. We just wouldn't have the internet connection to go see what the battery health would be at that point in time. So truly a UPS backup system for those
Yeah,
lights.
and I guess it would just keep on working anyway. Well, all that's good to know. So that was the small one. And speaking of small too, do you do any residential?
We can do residential. We haven't necessarily focused on that area right now. We're really more focused on commercial in front of the meter, looking at any type of commercial office building, multi-use office areas that you might have, any type of area where you may want to have some redundancy from a standpoint of, let's say, a larger home to where you might have a need for a larger one of our packs, which is about a 50 kilowatt hour pack that's there. So depending on the application, yes, we could do that. However, our focus has really primarily been on the commercial systems right now.
Sure, yeah. And so for commercial buildings, where are you putting the energy storage systems? Inside, outside?
Well, that's the great thing about Viridi. The way we have our architecture set up, it is really designed to be used indoor or in an outdoor application. Okay. Indoor, the way our architecture is, especially with the lithium ion batteries and the cell technology that we have designed around that battery cell, we have a phenolic buffer and we also have a passive cooling packet. So, in the rare event that you might have a problem with a lithium ion nickel magnesium cobalt cell going into thermal runaway, our systems will contain that and not propagate to the next cell.
So you're talking about the NMC. So that N stands for nickel,
Nickel,
M for manganese, and C for cobalt.
right?
And that's lithium, nickel, manganese, cobalt oxide is that type of technology. Are you using that technology?
We are. We use the
Oh,
LG 18650 cells, which are some of those popular.
okay. That's what's in my car. Yeah, those are cylindrical cells. Yes.
Correct.
Okay. Yeah, I have 7,000 of those in my car.
Well, and we have on our 50 kilowatt hour packs, we have about 4,300 of those in a
Okay.
single 50 kilowatt hour because it does have the best amount of energy density associated with that.
Yeah, so I know a lot of the energy storage companies have been switching to LFP, that's lithium iron phosphate. So that's interesting that you are still using the NMC technology, which got more specific energy. That means energy per weight, and more energy density, that's energy per volume. So that's good to know that you're using that and it doesn't take up as much space and it's not as heavy for the commercial applications that you're using them for. And another thing too that I noticed that was mentioned on a press release and on your website is it something about first fail-safe lithium-ion battery systems for use in industrial, medical, commercial, municipal, and residential buildings.
Mhm.
So maybe you could talk a little bit about that. What makes it first and what makes it fail-safe?
Well, first of all, let's talk about the first of a kind really being centered around the architecture. Okay. Because, as to your point, we have best quality cell, highest energy density associated with that cell. We wanted to make sure that the one thing that could go wrong with that cell is that thermal runaway event. So our architecture around there will basically contain any type of event that might happen within that thermal cell. We do that by using the phenolic plates that surround the cell, and then a passive cooling packet that is completely surrounding of not only the cell, but the entire module that we use, which consists of about 16 of those cells that get bundled together. If in the event that one of those cells begins to overheat, that passive cooling technology will take care of that, but it will also take care of any concussive type of force that might come across there. If you've ever seen these batteries burn, when they do get into thermal runaway, it is like a small little grenade going off in there. Particulate matter starts getting pushed out of there as it gets to that point, and it goes past that cell cylindrical wall that it has. It'll projectile components out there. The phenolic buffer keeps that from projecting anything into the next cell, and the cooling packet cools that down. In addition to that, when you start talking about the IoT solutions that we are also monitoring how the battery charge and the discharge cycles are going. So we never charge the battery too quickly, and we never discharge the battery too quickly. So we keep it within the parameters that LG 18650 likes, and we really never get ourselves into a situation that you might be close to having a thermal runaway. But we've tested these cells not only in the lab, but we recently were out at a battery demonstration test with a little over 450 municipalities that came and witnessed what thermal runaway events were like. And while you can see what an 18650 cell looks like when it lights off, you can see what a computer laptop battery looks like when it lights off, or one of the cordless drill sets you might have in your garage. When they got to our battery and our architecture, it was really called a battery non-burn event, because all you could see was the thermocouples that we had in there showing to heat up, and then the cell ignite, but then the passive cooling packet takes into effect, and then of course cools everything down, and the other thermocouple cells that are adjacent to the other battery cells, they never reached anywhere near the point of getting to that ignition point.
Great.
So
Wow.
we call it a battery non-event because technically you didn't really see a whole lot, but you did see the data coming through, lighting off the temperature of the cell, and then that not propagating to the next cell.
So just to put it in perspective to these cells, 18650, it's 18 millimeters by 65 millimeters. So I don't know, it's bigger than a AA battery, but smaller than a C battery, I guess you could say, the size of it. And so you're saying like when one cell, not just the packs, but when one cell has a thermal event, that means, catches fire or whatever, it doesn't catch the next cell on fire?
That's correct. Right.
Okay, wow.
And that's the key thing about making sure that our technology was able to be protected so that you can put these larger systems indoors. And that's what we've done at the Hoffman Woodward Research Institute up in Buffalo, New York. We have a 600 kilowatt hour system operating up there for the electron microscopes that they're using. And that really came into play because the power company and having to add additional amperage to that building, they were only looking at utilizing those electron microscopes for maybe 2 to 4 hours a day. So the batteries are there to help augment that power supply that they need while they're using those electron microscopes.
Okay, great.
And I think that's one of the largest battery storage systems that is actually located indoors up there in Buffalo, New York right now.
Oh, great. And so a lot of times I hear people talking about UL 9540A, and it's not necessarily the cell catching another cell on fire, but it would be you have one energy storage system and maybe something like 10 kilowatt hours for residential, and it doesn't catch the one next to it on fire. That's usually what I'm hearing people talk about. And they have to keep it 3 feet apart in the garage or on the wall or something like that, unless they go through these UL 9540A tests. And so you are doing that on the cell level, which is, if that's even better.
Yeah, we're doing that on the cell level to make sure that we have the 9540A, which is that cell, and also the module level test for evaluating that thermal runaway propagation there. But then also getting our packs UL 9540 listed such that the entire system is set up and evaluated for functional safety. We currently have done a little over 125 field evaluated certifications that meet the UL listing requirements. We shouldn't have the full UL listing that we can actually put on at the factory here, looking to complete that here in fourth quarter. So once that happens, we're going to have all of our packs ready to go, those 50 kilowatt hour packs ready to put together.
So what's the trick of getting one battery cell not to catch the next one on fire? You said something about some kind of plate. What's that plate again?
Yeah, it's a phenolic plate.
Phenolic. What is phenolic?
So think about a ceramic plate that
Hmm.
is basically cordoning off each and every cell.
So a plate. What do you mean by plate too? Like not a dinner plate, I guess.
No, no, more like
You're
a
not spinning them on the wheel.
not at all, not at all. Think about it as a buffer wall. Okay, so a phenolic buffer wall that is surrounded on four sides of that 18650 cell.
So it's an 18650 cell with ceramic all around it. So I know that the 18650s usually just have metal around them. So you also have ceramic around them, which is an insulator.
Correct. That's absolutely right.
I guess you could say an electrical insulator and also thermal.
And definitely, we look at it more from a thermal standpoint, but you're right, it would definitely be an electrical insulator also. And that really, those phenolic plates that we use keep that heavy concussive force after you do have a thermal runaway event, any of that particulate matter going to the next cell and trying to penetrate through that 18650 cell that might be adjacent to that.
Okay, great. That's really interesting. Is that some sort of patented technology that you have?
It is. It's Viridi's patented technology that we have on that.
Uh-huh. And so you're buying the cells from LG, that's a South Korean company,
Mhm.
and then you are taking them and then you're putting these phenolic plates around them, putting them into your battery packs, and then turning them into energy storage systems.
Exactly. And the great thing about it, Viridi has made significant investment in a lot of a lot of automation within our factory out there
Hmm.
now. So a lot of the robots are taking each one of those cells, putting them into the module packs that we have. Each module has 16 cells per pack, putting the phenolic plates in between each one of the cells, putting the passive cooling packets over that, and then creating a full module that's stackable into creating a full pack.
And so a couple of times you've mentioned passive cooling.
Mhm.
So do you have active cooling also, or is it all passive?
Well, depending on the size that we have for our packs, we have passive cooling on the 50 kilowatt hour pack and the 150 kilowatt hour pack. And when I say passive cooling, each one of the architectures that you have on the cell modules have a cooling packet itself. So in the event of a thermal runaway, that pack will break, and inside there is distilled water and some other ingredients that will basically wick its way into that cell.
Hmm.
The overall pack itself, because you have that type of architecture, does not require any type of mechanical cooling within those systems.
So is that sort of like a chemical reaction when it cools it? Like you can sort of get like these cold packs if you hurt yourself and you twist it and you break the little bladder and then it gets cold all of a sudden. Is it something like that?
Well, you don't have any thermal reaction inside that pack. What it is what they call a cool pack, KUHL pack. It was used on the Mars rover for some of their systems that we had, and they
How did you get it back from Mars?
well,
Just kidding.
well, no, but it's great to have something that was actually being used up there on another planet. So these packets really worked well from that passive cooling standpoint because we knew that in the unlikely event, okay, and this is really what you're doing, you're really focusing on safety. In the unlikely event that you did have a thermal runaway, you didn't want to have a whole lot of active cooling systems that had to activate, especially within a short time period, right? You
Mhm.
want something that's always ready, always available at all times. So no matter what, safety was always going to be a number one factor as we were looking at designing these systems.
So let's say there's a thermal event. Does it melt something and then it releases the coolant?
It does. And
Okay.
think about it, it's an aluminized pack. If you look at it, you would probably say, well, it looks like a ketchup pack. All right. And
Uh-huh.
inside there is the coolant so that when you do have that thermal runaway situation, that pack will burst and that coolant will come right to that area where that thermal event happened and cool that cell down.
Okay, cool. And then but those little packs, if you were just out of curiosity, if you were playing with one, and you squirted it on yourself, would it feel cold?
It would be more room temperature than anything else.
Hmm.
It would be
But
the ambient temperature of wherever the pack would be located at.
hmm. Okay. All right. But that ambient temperature is enough to prevent thermal runaway, I guess.
Absolutely. Just think about it. It's really distilled water inside the pack that's kind of opening up and coming down and cooling the cell down.
And it's about the size of like a ketchup package.
Yeah, a little bit longer than a ketchup package on the top end of the module itself. And then we have larger ones that are on the side of the module. So the entire modules are completely covered in each one of those cooling packets.
Interesting. And is there one for each cell of the smaller ones?
There's not one for each cell, there's one for each module, which consists of 16 cells.
Oh, so that's enough to cool off the cell, just one for each module.
Well, yes, and of course that surrounds the entire module, the top, the bottom, and each one of the sides. In the event that you have that situation, you'll have enough of that cooling packet opening up there to cool that one cell down.
Okay. So you have a bunch of cells and that makes up a module. And then you have multiple modules that makes up a pack.
Correct. About 270 a month.
Kind of reminds me of solar. You have solar cells, solar modules, and then solar panels, which are multiple modules, or at least the older definition until they changed it in the 2020 National Electrical Code. So with batteries, instead of saying panels, you say packs, which also starts with a P.
Yeah, there you go.
That's how I
Makes it
remember
real
it.
simple for the makes it real simple for the industry, right?
And so once again, maybe we could just kind of give the numbers. So how many cells are in a module and how many modules in a pack?
16 cells in a module,
Hmm.
and then you have 270 modules in a pack.
Wow.
This is a 50 kilowatt hour pack.
Okay. And that makes
Um,
50 kilowatt hours, I guess.
Next 50 kilowatt hours. Yep. And then, of course, you take those packs and you can combine them into a 150 kilowatt hour mobile system, which is one of our more popular products that we have out there right now. We use those on a lot of the mobile systems that we deploy out there to the field. And then we build those packs on the 150. We can scale those all the way up to the 1.2 megawatt hour systems. Now, in those cases, Sean, just given that we're putting those in a 20-foot containerized setup, we do have active cooling systems on there just to make sure the container stays cool. But the architecture of the module, the architecture of the 50 kilowatt hour packs that we have, that none of that changes. That's also still in place there. But due to the fact that especially the 1.2 megawatt hour containers are much larger, a lot of metal around there. You want to make sure that whole inside is taken care of, not only for the batteries, but also the IoT systems, the battery management systems, the inverters, and everything else we do actively cool those systems.
So for the ones that are not actively cooled, do they
Mhm.
even have fans in them?
They do. They have a convection fan in there. There's no mechanical cooling. We're just pulling the air
No air
across the fans.
conditioning type of stuff. Yeah. Hmm.
Right, right. So we're just pulling the air out of the cabinet that we have in there to make sure everything stays cool. Because the batteries kind of run about 2 to 3% higher than ambient, give or take, is what we're seeing.
Okay. And what about for times when it gets below freezing? You have heating?
We don't need heating. We've actually run these batteries up in cold weather environments, and it's part of the architecture associated with that nickel manganese cobalt. You can actually run those batteries down to a lower temperature without having any degradation.
Hmm. Okay. All right. Because I know a lot of times they say that with most any lithium ion battery that you can't really charge them much below freezing.
Yeah, no, we haven't really, we've operated these down into negative 20 degrees Fahrenheit and haven't had any issues on a lot of our microgrids that we've set up there in the north during the winter months.
Okay. Wow, that's kind of
Yeah.
interesting. And so for the active cooling for the larger ones, so those are container based. And how does the container one work? Is it a container that people can go inside of, or do you access it from the outside?
So it's a cargo container that we have taken and we put in racking systems such that you're able to take a 150 kilowatt module and put it into the rack system. You have access on the side of that cargo container panel by opening it up. And then in the front of the panel is where you have access to all of your connection points. So all your breakers, your IoT, your battery management system, that is all accessible from the front of the container.
So you don't have to go inside of it
You wouldn't have to go inside of the battery pack itself. No,
or inside of the container?
no, we do make it to where you can access those battery packs on the side. and then pull individual packs out as necessary that are in there. So think about 150 kilowatt hour packs kind of put in a racking system on there. You can use a forklift to come in there, pull those packs out of that system if they ever have a problem or ever need to be replaced.
Mm-hmm. Okay, interesting. And so is it like a 40-foot container?
A 20-foot cargo container.
Okay, great. 20-foot container. And how much did you say that was? Was that 1.5 megawatts?
That'd be 1.2 megawatts nominal, megawatt hours nominal.
Or excuse me, megawatt hours. I just broke my own rule.
That's okay. to 1.2 megawatt hours at 240 kilowatts.
Okay, so that's 240 kilowatts. That's the rate. That would be the inverters.
Right.
And then 1.2 megawatt hours. And that is the total storage inside of there. Okay, great.
Right.
And another thing that I noticed too is that on your website and even on a different website, first of all, I guess we'll say that Sunbelt is renting out some sort of energy storage system that you have.
They do. Sunbelt's one of our largest partners out there, and they're renting out our battery energy storage systems. They utilize them in a lot of different locations throughout North America, a lot of different sites, a lot of different environments that they have out there. Deploy those out in both a gen hybrid configuration, where it's just running off of a single pack with a generator to charge the battery. And then, of course, we've also set up multiple microgrids out there with their systems too.
Yeah, so I thought it was kind of interesting too. On the Sunbelt website, it says that they're parallelable. And I kind of like that word parallelable. So when you connect an inverter to the grid, that's called parallel to the grid. And it's probably not a rental that you're going to connect it to the grid, because connecting to the grid requires, an interconnection agreement, and it's kind of more of a permanent thing. And maybe somebody has like a generator that they're working with. And
Yeah, for the stationary ones, we definitely would want to have some kind of agreement in there, connected to the grid, have it charged there,
oh,
or
it does connect to the grid.
it
Okay.
absolutely can. So we can use it either stationary mode or we can use it in a mobile capacity. And then these systems are set up for any type of renewable sources. So if you're running off of a diesel or natural gas genset, if you're running off a photovoltaic, if you're running off a wind turbine, we can bring those all into our systems. And then, of course, to your point, if you want to connect it up to the grid, charge it off the grid, do peak shaving, do demand arbitrage, we have those capabilities there with our systems.
But that's probably not one you're going to be renting temporarily from Sunbelt.
Now, those cases, and the majority of those are going to be rental applications, and they're going to be mobile.
Yep. But on the Sunbelt website, it did say parallelable. So maybe it means that you could put a bunch of them together to make a little microgrid for your project. Maybe somebody's going to be building an energy storage project or a solar project or something like that. And they could bring over a whole bunch of these, batteries, I guess.
Yeah, definitely so. We can take the batteries and can put them in parallel from a single system. We can actually put 14 of our 150 kilowatt hour packs together in a microgrid,
Wow.
and
Okay.
then link all those together with our smart BMS system, such that as you connect these to a generator, or you connect them to a whatever source you're using out there, PV or diesel, natural gas, whatever it might be, the BMS system will automatically detect which battery is being charged and discharged, which one needs to be refilled across all 14 of those, in addition to making sure that things are synced up with that genset. So as you start that generator, you want to make sure you get it to 60 hertz. You want to make sure it's synced with the battery charging cycle that it has on there. Make sure they're all communicating properly back and forth. And this is the benefit of our building our battery management systems that we have out there.
Yeah, I imagine probably people listening right now, some of the people are working on solar projects and they have big generators going all the time. And sometimes they turn on a big generator just to charge their phone, which is kind of ridiculous, or some kind of small loads. And so that would be a big benefit. So you don't have to have that generator cranked up all the time, is to use that with batteries or maybe even with some solar. And then you have a microgrid, and then you can install your renewable energy project with renewable energy. Or perhaps even at nighttime, they could take the truck back with the trailer with a battery on it to the shop and charge it overnight.
Absolutely. And that's a great flexibility you have behind the system. And to your point around the generator is only going to pull the amount of kilowatts that are required for that load. So a generator may be operating at a very low load. One thing we've seen on the generator side is when you are operating those low loads, the diesel's not burning effectively. Okay. And you get what they call wet stacking, which is that black smoke coming out of the back of the generator. You also get the unburnt diesel fuel coming out of the discharge. And you see this when it's running at that lower loads. Well, when you have a battery system, you can sit there and say, all right, I want to charge my battery. So let's take a 150 kilowatt hour pack. We have a charge rate of a 0.2. All right, so we're going to charge at 30 kW. I'm going to run my gen set at 100% load, and I'm going to charge my pack up. It takes about 4.5 hours to charge the pack up. After that, I'm going to shut my generator off. The amount of fuel savings that you have that we have seen is going to range anywhere between 60 to 80% by doing it that way. And all because that generator is not running at that part load. Any type of mechanical system that you have out there, it has optimizational areas where those systems truly need to operate at to where you get the most efficient fuel usage out of it. And in this case, those gen sets running at the 100% load is where that's going to be.
That's why they even say the hybrid cars work better for efficiency is they run the motor at its most efficient torque and RPM, and then they have a battery to assist with that, even though some of these hybrids you can't even plug in.
Right.
So,
and we don't have enough EV charging stations out there in North America either right now. I feel for a lot of people that need to make a long distance run to where they can't find charging stations in a timely fashion. There's been a lot of people that I've known that actually been stuck in certain cases where they couldn't get to a charging station in time.
Yep. Well, since I don't go too far from home with my car, I don't have that problem because my charging station's at home.
That's always good.
Yeah. But if people are going to go on long trips, they have to figure that out. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And so we talked a little bit about Sunbelt, and it looks like on your website too, there's also a relationship with Bobcat. And so that's Bobcat's, not the one with the weird ears, not the cat with the weird ears, but the tractor.
No, all the construction equipment that's out there and everything else. And it really came from our founder, John Williams, looking to electrify a lot of the construction equipment that was out there in the marketplace. So we currently have commercial equipment that is capable of doing that, operating on a battery system.
Wow. Are they electrifying the skid steer, the Bobcat?
Sean, I'd have to check on that one.
Okay.
I'd have to see how detailed he wants to go into that component of the business.
Okay. All right. Yeah. Yeah. So it'll be nice when they do that. But I know that with construction equipment that's moving dirt and rocks and all that kind of stuff, it's the problem with the electricity. It's sort of like long range on a car. You want to run that Bobcat 8 hours a day and you'd have to keep charging it and things like that.
Yeah, I think that the biggest point is, not having to use all the diesel fuel, the amount of savings that you have to where you can just go back and recharge those batteries and then put those back into the system. And the other piece too, and this kind of comes up a lot around construction equipment in general, they operate much quieter. Okay. You think about a gen set on a light kit out in the middle of the night when they're usually working on a freeway system or something like that. Well, those generators make a lot of noise. If they're located next to a residential housing unit or something, there's a lot of noise pollution that's coming through for the genset. Well, you can operate these light towers off of batteries and make them run all evening long and then recharge them during the day when you don't have that noise pollution problem at night.
Great. I heard of an interesting application too, because since we were talking about construction equipment, an electric dump truck, and there was a mine at the top of a hill, and it goes up, loads it up with rock, or I should say a quarry at the top of the hill, loads it up with rock, and then goes down the hill, regenerative braking, and it never needs to charge the battery.
Battery back.
So,
Just automatically as it's coming down, it's using gravity
yeah.
to basically go ahead and recharge that battery back and forth. Yeah.
Uh-huh. Yeah. So kind of an interesting application, getting that gravity energy out of that hill to make the dump truck work. And then as talk about having no range anxiety with that, you could go perpetually forever
Mhm.
doing that. So
Well,
kind
and
of,
I think even your car batteries that you have now, if you have a hybrid unit right now and you're going downhill, you're charging that battery system back up where possible.
yeah, hybrid or electric car. My car will do that. So I'll charge up those 18650s, all 7,000 of them.
There you
And,
go.
and when one of them breaks, I'm going to borrow a couple from you. Another thing that I was just thinking of too would be kind of interesting is I know that there's different climates around the US, different utilities, different grids, and they call it the solar coaster, or maybe we should start calling it the energy storage coaster too, where there's going to be little problems on the grid seasonally in different places. So we can take 100 train cars, fill them up with your energy storage system containers, and then take them to places where there's going to be a problem. Like where in Texas, we had a couple of different problems when the grid went down, when it was super cold and stuff like that.
Mhm.
We could take it to where there's forest fires, all that kind of stuff, or just, park it where it's going to get the most, I don't know if we should say bang for the buck, but have the greatest effect on the grid. You bring the train there with the energy storage system. So that would be kind of an interesting application. So I'll let you take that idea from me.
Well, it's interesting. I haven't seen it with the train, Sean, but that's a great idea. I'd love to put all those batteries on a train and just haul them around wherever we need to. But we are seeing very large battery farms really starting to come to fruition. Great example is down in San Antonio here in Texas. CPS is working on a 200 megawatt battery storage farm. Up in Maine, just read an article the other day on that one up there. It's going to be about 130 megawatts they're looking at. So all this is to supplement that grid. And then, of course, as you remember down in Texas, back when ERCOT had the issues here where they had the big freeze coming through, they were shut down for days and almost weeks in some areas without getting power back to people. So they're looking to augment battery energy storage systems to make sure that that grid is much more resilient, to make sure they have the capability in the event of an emergency to tap into either the battery farms here in Texas or even from a virtual power plant. How do you regulate that power to make sure it goes where it needs to go in the event of a situation or emergency?
Yeah, so you mentioned the virtual power plant, the VPP, and I've talked a lot about those. I think it's the future and it's fascinating being able to control where the electricity goes so you get the best benefit and you turn things on and off, not just the energy storage, which is a source and a load, and the sources, which are the power plants, including solar and wind and fossil fuels, and then the loads, just coordinating all that stuff to work together and perhaps with the electric vehicles and all that stuff. And so I noticed that some of the things on the Viridi website were also talking about, AI, seemed like software kind of stuff. I don't know, is it with server farms? And is one of the big things that you're working on the software?
We really are. And it's critical when you take a look at those battery management systems to be able to analyze and optimize. Okay. You can automate what the information is coming through. And that to me, the automation is really the ability to just kind of prepare a dashboard to put the information that's coming back from whatever measuring device you have out there. The optimization software that we have in our battery management systems, it's also taking a look at, okay, well, how are we looking at that battery? Is it running at its most peak efficiency? Is it discharging? Is it charging? Where are those components at? How do we control all that coming into the battery system? And then trending and monitoring that so that we always stay within that optimal performance of where that battery is going to operate at. And some of that comes back to the AI capabilities of what we're doing in our algorithms and our programming that we have with our battery management systems.
So do you have like a whole bunch of people that are coding and making software for you, or do you work with other companies that do that?
We have our own internal controls team that does that with Viridi,
Mm.
and they've got our algorithms that they put together to specifically take a look at what we're doing with battery management systems, and then also making sure that those algorithms are also put together for whatever type of renewable source that we want to bring in to charge the battery. So linking that information together, great example there around the dice systems that we use for the controlling of the gen sets, how that all works out to make sure that things are synced up together on the charging side. Photovoltaic side, what are we doing from the photovoltaic cells, pulling those in? All that kind of comes together with our own internal controls team.
Great, great. Okay. And I was doing a search on the internet and I noticed that there was another company, or maybe it's the same company or some relation, Viridian.
I'm not familiar with that,
They
Sean.
had a similar logo and they were doing tactical stuff and they had like some batteries that they were selling on Amazon and they were like Viridian and it looked like a similar logo. Like it looked a lot like the Viridi logo. And I also know that you're in the military and you're a United States Army officer and went to West Point. So thank you for your service. And so I thought maybe there was some kind of relationship, but apparently not.
No, no relationship there. Yeah, I was Army officer for about 13 years in between active and reserve status that I had on under. I've been very fortunate that we've had the opportunity with Viridi to be able to leverage the products that we have with what they are working with up at the academy right now, which is tactical microgrids that they're setting up out there. And we recently deployed one out to the academy summer training where they train the field cadets or the cadets in the field to go out and both do land navigation sites as well as making sure that the tactical operations center, the talk that's kind of controlling everything, making sure that they're taken care of out there from a energy standpoint in a very remote location outside of the West Point proper, where the buildings are, because they train about 9 miles away in a place called Camp Buckner out there.
Great, great. That's fascinating. So I guess if there was some kind of problem in the world, then one of your batteries could be deployed. One of your energy storage systems could just come out there and make some nice silent energy when it needs to be silent.
Yeah, there's no question about that. And this is one of the wonderful things that you're seeing about the battery technology right now. If you go back and you look at the wars that we have fought, let's take World War II, for instance, and you look at how much fuel was needed to take care of the soldiers that were out there, okay, whether that be transporting them from point A to point B, making sure that you've got fuel and everything you need for all your equipment stuff. It was about a gallon per soldier, okay? Because we have so much more electrical type of components and equipment and systems that are out there monitoring in today's day and age. And think about this, a soldier today, in the past, you might have had a flashlight with batteries, right? Okay.
Mm.
Well, now you have laser rangefinders, you have night vision goggles, you have reconnaissance elements like our scouts that have drone systems that they use. Okay. All these require batteries in addition to their radios that they have on them at all times. If you do what they call the mount training, which is military operations in urban terrains, they actually utilize some of the remote operating vehicles to go into the buildings, okay, before you actually bring a soldier in.
Mhm.
Cameras that are recorded each one of the operations, you use those for training to make sure, hey, are the troops training correctly? And then at the academy, what was interesting, in addition to them running all the computers, back in my day, and I'm what they call an old grad since my 35th is coming up here pretty quickly here. Uh,
Congratulations.
thanks. Back in the old day, when they conducted a land navigation course, they gave you a map and a compass, and you're out
Huh.
there with a little chem light that is colored red to make sure you had your night vision taken care of. And you would have to go to 20 different points. They give you these 10 different grid coordinate points, and at the top of the tree, they would set up a little basket, and you would either pull out a tile with a number or a letter on it and then mark it down. Okay. And you'd have to pass that course within a certain time period. And it's all done, of course, in the evening. They have a night land navigation and you have a day land navigation, but the night one was always a difficult one because you're tracing around a whole bunch of forest areas and a bunch of rocks and everything. Well, now they don't do that. What they do is they put a GPS locator on each one of the cadets. that are out there doing this. And so they can actually log exactly if they hit that specific point on the land nav cycle as they're hitting each one of these 20 points before they come back in. All that's logged back into a central computer, certain time limit that they have on there. So they know if a cadet passes and make sure they get past the training there for each one of them. So a lot more, just simple things like that. You look at each one of the individual soldiers having an individual GPS tracker on it. All those need to be recharged. Radios that you have out there that are tracking and monitoring as the cadets are moving through there. All the computer systems that they have for that training are all being operated, and we're being operated on our little microgrid that we set up out there. And to your point, the best part about it is I never have seen it because we didn't really have a whole lot of computers when I was going through back in my day. But in the past, they were running these off of gen sets. Okay, they're running a generator out there running diesel. And so the cadets kind of knew that where the generator was running at, they could hear that noise pollution coming from. So they knew how to get back to the starting point through that. Well, they couldn't do that this year because they ran off the battery and it's nice and quiet.
And then the bad guys would know where to aim too.
Absolutely. You have a thermal signature associated with the generator with that heat and discharge off there. And you also have the noise pollution. Well, you don't have any of that when you're operating on battery systems. In addition to that, we talked about the fuel savings because you can charge it up during the day when you really wouldn't have a big problem with that signature, but you charge it for 4 hours and you run through all your night operations with just the battery. So it truly does make a difference from an operational excellence out there in setting up these tactical microgrids. And of course, as you can imagine, when you start getting into larger battalion sized elements, now you have to think about bringing all that data that's out there, all your maneuver elements with tanks, your field artillery, your infantry, they're all being tracked via GPS. You're bringing that back to a tactical operations center, which has a maneuver control system associated with it to bring all that tactical information on where everybody's at on the battlefield, in addition to all the information you're getting from the enemy. So the tactical microgrid to run that requires an extensive amount of power. And this is really where our batteries are going to be able to help our forward deployed forces as we start looking at more of these in the future.
So are they still using magnetic compasses?
They still use magnet. It's always a great backup,
Uh-huh.
just in the event that whatever reason the satellites might go down. And of course, that's a real concern there from a cybersecurity standpoint. So yes, they do have to definitely use their compasses in order to navigate to where they need to go and understand how to have that land navigation through there.
And I was also looking on the Viridi website and it talked about zero noise. And I had a guy on the podcast and I also met another guy at a conference in Texas, actually. I was at RE Plus in Texas, and maybe you were there too. Were you there?
I didn't get a chance to make that one. I know we got RE Plus coming up out here in California, which John and our business development manager, Hal Corin, will be at. They're in Anaheim coming up. So great conference from what I understand, though.
Yeah, and we have a big backlog of shows. So we could just say, wasn't that a great conference? Because it's going to come out after the show.
Fantastic.
And so anyway, I had a guy come on and he's like a noise engineer and he works with keeping solar and energy storage power plants quiet. And so sometimes you just have the cooling systems for the inverters and things like that making noises that bother people. And I noticed that your energy storage systems are zero noise, or maybe not all of them, but at least I read something about that on the website. And so that would be a big extra benefit, and probably something else too that has to do with a lot of your systems are passively cooled instead of actively cooled. So they don't have, like pumps in there pumping, like an air conditioner type of a pump, something like that, heat pump.
Right. Yeah. No mechanical HVAC air conditioning coming through there. What we do have are some very small fans that are doing that convection cooling across the batteries there, but minimal noise coming out of there. So definitely would not be impactful if you were in a field operations out there from a tactical standpoint.
I'm sure if the bad guys are looking for you, you could probably turn off the fan if you had to.
If you had to turn it down, again, you'd have to have some pretty good hearing to hear these small fans that are operating through there. But if you had to, sure, of course, you could shut the battery system down in that situation.
Great. Well, yeah, it sounds like a lot of fascinating stuff that you've been dealing with. And I was thinking also, too, just maybe a little bit more about your factory. So you're up there in Buffalo and you're probably working with the Inflation Reduction Act. And because I know we're trying to get everything made in the US that we possibly can. So you're assembling the components, I guess.
We are, and we're purchasing the LG 18650 cells from China or South Korea. We can
Mhm.
source from either one. The good news is when we bring those cells in, pretty much everything else is being done in the US.
Great. And then how about battery cells being made in the US? I know there's people that are starting, they're building factories, but when is that going to be more available?
Well, I think there's one in North Carolina that's being built right now. I heard it's going to be coming online sometime in 2025. I'm not sure if they're going to build the cylindrical cells like that. I think there's more evaluation that needs to be done with those type of systems because, again, it's tough to build the batteries. It's tough to do it correctly. There's a lot of testing that has to go on to make
Mhm.
sure you get a factory up and operational. We focused in on that LG 18650 because it has had a long life associated with that where it hasn't had any issues. And there's roughly about 500 million of those cells out there currently operating right now.
Yep. And like I said, 7,000 of them are mine, and they've been going for 9 years, about 85,000 miles. That's about a mile per kilowatt hour, or 1,000 miles per kilowatt hours that I have.
With no problem at all, right?
No problem at all with the batteries, a little bit of problem with the software and the service and all that kind of stuff.
Yeah, which is usually the case, right? The
Uh-huh.
batteries are going to do what they need to do, but everything else that's connected to that you might have an issue with.
Yeah, and I also blame the manufacturer for the guy that smashed my window, you know.
Oh,
I'm
well,
just kidding.
that was out of your control, though.
Yeah. Yeah, the darn window smasher. I'm going to find those people. And you can help me come after them, and we'll be silent with your batteries when we sneak up on the window smashers.
Well, you do know, Sean, I was trained in the military, so I would be happy to assist in any way, shape, or form,
Yeah,
as
let's
long as it's within the laws of the United States government.
okay. Darn, we have to obey the law, but let's do it. Let's get those guys.
That's great.
All right. So let's see. Is there anything else that we should cover?
Look, I just appreciate the time. This is really fantastic, having a great discussions around our batteries and our battery product. Thank you for allowing me to talk about the wonderful work Viridi's doing out there with the United States military. And I know we're going to have future opportunities to help our soldiers and sailors out there in the field, and appreciate all of the commitment that our young men, women, and anyone that's currently active or veterans in the service have done for this country. It's just amazing. I would be resident if I did not say go Army, beat Navy,
Okay.
because I just want to make sure we put that out there. My son, I'll little plug here, he actually fell a little bit further from the tree and decided to go Navy. He's an E6 in the Navy right now. So I love him 364 days out of the year, but the one day that we have to play Navy, I'm sorry, I have to disown
Uh-huh.
him. So
Well, good for you knowing where your allegiances lied.
there you go.
Yeah. Okay. Well, thanks so much, Wayne Garrett. And thanks for being on the podcast. And another thing, too, is where do people find you and Viridi?
You can find us at www.veridiparente.com. And you can reach out anytime to me personally at wgarrett, Garrett, at veridiparente.com.
Great. Well, thanks so much, Wayne. And we are going to put all of that contact information in the show notes. And thanks for listening to Sean White's Solar and Energy Storage Podcast. If you want to find out more about solar and storage, or how about getting yourself NABCEP ESIP, that's Energy Storage Installation Professional Certified, go to Solar SEAN, that's solarshawn.com. Thanks so much,
Great.
Wayne.
Thanks. And I'm going to go to solarshawn.com and get my certificate going.
Yeah.
Because I haven't done that yet.
Great idea. Yeah.